Alrighty, welcome back. We are going to pick up with number 16 of our geometry review. Our directions are: give the symbol that represents the portion of the line named and draw a figure showing just the portion named. Line segment QR. Line segment QR would mean that endpoint for Q, the portion of the line in between, and that endpoint for R. So we're essentially looking for that symbol above QR. These two arrowheads mean the line QR, so extending beyond those 2 points. We want line segment QR, so it can't be A. B and C both have the correct symbol here, line segment, a portion of the line with strict endpoints. But if we're talking about the segment, it's got to be B because it truncates the line at those 2 points. So number 16 must be B. Number 17. Ray RP. Ray RP. Well, our symbol for a ray above the actual letters looks something like this. This is the ray. So that eliminates C and D. Now R is right of P. So the actual ray is beginning at endpoint R and going through point P. So that means we're looking at B as the correct answer for 17, the orientation. Number 18, half line SP, half line. Well, the point at which the half line technically begins is not included in the half line. So we would have an open circle at S and oriented to the left through point P. So that eliminates A and B because their orientations are both to the right. Between the symbolism for options C and D, we have to go with D because, again, the half line does not include that initial starting point, so it's got to be an open circle at S. So 18 must be D. Number 19, find the measures of the angles. Angle A and angle B. Okay, well, according to the little given information below the figure here, the measure of angle A is equal to 13F. The measure of angle B is equal to 3F. Together, they create a right angle. So they are complementary angles, meaning the sum of the measure of angles A and B should be 90 degrees. The measure of angle A plus the measure of angle B should be 90, which means 13F plus 3F, which is how A and B are defined. That sum should be 90. So 16F is 90. Divide both sides by 16. That gives us at least the value for the variable F as being 5.625. But that does not actually answer the question. We're supposed to find the measures of these angles. So I have to plug in the 5.625 back in for both A and B. So plug it back in for F. 13 times 5.625 is going to be the measure of angle A. And that comes out to be 73.125. And 3 times F, which was 5.625, ends up being 16.875. And that is the measure of angle B. So that corresponds to option D, 73.125 and 16.875. So 19 is D. Okay, number 20, again looking to solve for the measures of angles A and B. Well, this time A and B are coming together to be a straight angle, or they are pairs of supplementary angles, meaning that the measure of angle A plus the measure of angle B is going to be 180 degrees. A is defined as 5x minus 48 plus B is defined as 3x plus 20. And together they are equal to 180 degrees. So combining like terms, 5x and 3x are going to come together as 8x, and negative 48 and positive 20 are going to come together as negative 28, equal to 180 degrees. Add 28 to both sides, and we get 8x equals 208. And then divide both sides by 8 to get x by itself, and x will be equal to 26. Now, we're not done. Again, this is just the value of the variable. We were tasked to find both the measure of angle A and B. Measure of angle A is 5 times x is 26, minus 48, and this will be 82 degrees. The measure of angle B is 3 times x, which is again 26, plus 20, and this will end up being 98 degrees. So 82 degrees, 98 degrees, that is going to be C. 20 is C. '21, still finding the measures of angles A and B, except this time A and B are vertical angles. So we know that one convenient property about vertical angles is that they are congruent in measure. So in this case, the measure of angle A is equal to the measure of angle B. A is defined as 6x minus 59. B is defined as 3x minus 11. So combining like terms, move the 3x over, subtract it from both sides, we get 3x on the left-hand side. If we add 59 to both sides, we end up with 48 on the right-hand side. 3x equals 48. Divide both sides by 3 to get x by itself. X, the variable, is 16, but we are not done because I have to plug this back in to find the measures of A and B, which are in fact the same because they are vertical. So if I just plug it into one of the equations, that should be enough. 6 times x, which is 16, minus 59, ends up being 37 degrees. And since they are vertical, this is both the measure of angle A and the measure of angle B. So both being 37 degrees makes C our answer for number 21. 21 is C. All right, number 22. Use the properties of parallel lines to solve the problem. Assume that M and N are parallel. So this line is parallel to this line. Find the measures of angles A and B. Okay, well, A and B are alternate exterior angles. Alternate exterior angles. So that means that they are congruent in measure by definition. So the measure of angle A is equal to the measure of angle B because they are alternate exterior angles of parallel lines cut by a transversal. A is defined as 5x minus 5. B is defined as 4x plus 26. So subtract 4x from both sides. Add 5 to both sides. X is equal to 31. Since they are both equal, it doesn't matter which equation we plug 31 back into. I'll pick the equation for angle A. 5 times x, which is 31, minus 5 is going to give us 150 degrees. And that is, again, both the measure of angle A and the measure of angle B will be 150 degrees because they are alternate exterior angles. So the answer for 22 is B. 22 is B. Number 23, in the figure, line segment AB is parallel to line segment CD. So this line is parallel to this line. We are to identify all pairs of congruent angles, so all angles that have the same measure. Okay, well, we can imagine that if this ray were continued in this direction and this ray were continued in this direction, Then we would have two parallel lines cut by a transversal, in which case we would have alternate exterior angles congruent. So that means that this angle and this angle would be the same of the original picture. And we would also have alternate interior angles congruent. So that means that this angle and this angle would be the same of the original picture. So ignoring what I have drawn in here. So let's see, that is angle ABE and FCD. ABE and FCD. And also ABC and BCD. So that's this one. So it must be B. 23 is B. In numbers 24 through 28, we are to identify the curve as simple, closed, both, or neither. So as a quick review, it is a simple curve if it does not intersect itself, so you never pass through any point more than once. It is closed if there's a very clear starting and ending point, and those points are in fact the same, so there's no openings to the figure if it is closed. And then combinations of those two definitions together mean that they are both simple and closed. If neither definition holds, we say neither. So in number 24, we could start in one place, trace the figure, never cross over anything else, and end back where we started. So that is both simple and closed. So number 24 is C. Okay. In 25, when we trace the figure, I would definitely pass through that point more than once. So it is not simple. And because the starting and ending points are not the same, we've got this kind of weird opening here. It is also not closed. So 25 is neither. 25 is A, neither. Okay. In 26, we've got like the infinity symbol looking here. No matter where I start on the figure, I would definitely end up back at the same point. So it's definitely closed. But because I pass through this point more than once, it is not a simple curve. So 26 is just closed. That makes it A. 26 is A. All right, number 27. 27 is definitely closed. One way I like to think about the definition for closed is if you were to imagine that it was fencing and you put an animal inside the figure in some place, could it get out? Is there an opening? Well, pretty much everything in here has a very clear boundary to it, so it's definitely closed. But if I were to try and pick a starting point and traverse the figure, at some point, no matter how I trace it, I'm going to hit certain areas more than once. So it's definitely not simple because those points that I've picked out, no matter how I trace it, I'm going to hit those points more than once. So closed, but not simple. 27 is A. All right, 28. I pick a starting point. I would never come back across a point, so it's definitely simple. I would not retrace any point. But if I were to, put an animal somewhere here, obviously it has an escape route, so it is not closed. It is simple, but not closed. So 28 is B. Alrighty. 29 and 30 will be our last two problems for this little video. decide whether the figure is convex or not convex. Okay, well, the definition for being convex means that I could pick any 2 points inside the figure, and if I draw a line connecting those 2 points, the line also stays completely inside the figure. That's the definition for being convex. Well, that's not the case in number 29. If I pick this point right here, which is inside the figure, and I pick this point right here, which is inside the figure, the line that connects those 2 points does not stay entirely inside the picture. It goes outside the picture. So 29 is B, not convex. B, not convex. Okay, in 30, it doesn't matter which 2 points you pick inside this figure. The line segments connecting them will forever stay inside the figure. So 30 is A, convex. And we will pick up with problems 31 through 50 in the next video.